Record. Okay. So we'll go ahead and get started. So this is test 4. It's one of the more concentrated tests in the entire class because it's strictly on chapter 6, which was confidence intervals. So section 6.1 through 6.3. So we'll go ahead and we'll get started. One of the things that we do have to be able to find is the ability to find a critical Z-score that corresponds to the 94% confidence level. Let me kind of show you how that works. So in general, you can use this formula or this result when we're done, but when we want to find Z-critical, so let's suppose we have some negative ZC here, some positive ZC here, and because it's Z-scores, remember that this goes with the standard normal distribution, so the mean, an ugly looking mean, the mean should be equal to 0, and the standard deviation should be equal to 1. For the 94% confidence interval, so if C is 0.94, then essentially what they're asking is what Z value, and for the Z critical, we always want it to be the positive of the two, has 0.94 in between the two. And here's how you can kind of find that. It's actually easiest to find the negative one, and to find a negative Z-score, we need to do the inverse norm. And then remember, it's going to be the cumulative area, which has to be the area to the left. To find the left area, if we do 1 minus 0.94, that would give us the two tails combined. So if we then divide that by 2, that would tell us how much area would be in the left tail. And this is how you're going to find it in general. For us, it's always going to be inverse norm 1 minus C divided by 2, kind of like we explained up here, comma 0, comma 1. And then just be careful with your order of operations. We need to subtract before we divide. So you'll want to either do it out by hand or put parentheses if you just throw it all into the inverse normal calculation. That will give us the negative ZC value. Just remember to switch the sign on it. Because when we say Z critical, or later on when we say T critical, we really want the positive of the two. So if you want to think of this as like a formula, you're more than welcome to use it for the test. For this one, to find the Z critical that goes with 94%, it's going to be the negative of the inverse norm of 1 minus 0.94, that would be 0.06, and then 0.06 divided by 2 would be 0.03. So this is 0.03, comma 0, comma 1, and then we just plug that into our calculator. If you forget the negative sign, it's really no big deal. Just remember at the end of the day, when you report a Z critical, it needs to be a positive number. So we could go to our calculator. I'm going to do second distribution. Should be choice 3 for all of us, inverse norm. The area, that's that cumulative area, you can either punch it in as 0.03, or if you want to do it as a calculation, you can do 1 minus 0.96, comma, divided by 2, 0, comma 1, hit paste, and this gives us the negative 2.05. Just remember to switch it should be positive 2.05. And did I do 96? Sorry, the one on the practice test was 94. If you just switch this over to 96 to 94, that's correct. Now we would get 1.88. So it's going to be 1.88. Does anybody have any questions on finding Z criticals?
And we always put that in 3 decimal place?
For the Z-score, I would say it depends. So the directions to the test will say it around to 3 places. 3 places is perfectly fine for this.
Okay.
Yep, great question. On the exam, by the way, too, I'm going to post this in the D2L announcements, but I'm going to put out a T-score chart, something that will probably come up, that came up in the lectures, and will probably also come up as we kind of go through the review, is that for those of you that have like a TI-83, the TI-83 does not have an inverse T function in it. So on the D2L announcement, I'm going to post this T-score chart for those of you that need one. But then in addition to that, this T-score chart will also contain all of the formulas for this chapter that you will need for the exam. So like when we move on to like example 2, when they say to find the margin of error, it's a large sample size, so that's going to be using a Z-score. So the margin of error formula, E, that involves the Z-score is this one right here. E equals ZC times sigma divided by the square root of n. And then the only real work that's typically involved when you need to find a margin of error is finding the ZC like we just did in example 1. They'll tell you the value of sigma, they'll tell you the value of n, and then the only thing left to find would be to find ZC. Would anybody like to see example 2 work through? Any questions on 2?
No.
No.
Okay. Let's take a look at example 3 then. So this time we're asked to find a critical value TC for C equals 0.95 and N equals to 16. Now there's 2 different approaches you can do. If you have a TI 84, there is an inverse T command. The inverse T command in the TI-84 accepts 2 inputs. We still need the cumulative area, which is the area to the left. And just like it was for the normal, the inverse normal, that's going to be your 1 minus C divided by 2. The second input, and this is very important, that it needs is the degrees of freedom. Okay. Now, what the degrees of freedom is it's 1 less than your sample size. So for this example here, if C is 0.95, we would plug it in as the inverse T of 1 minus 0.95, comma 2, and then we need to put in the degrees of freedom, which would be 16 minus 1, which is going to be 15. Second distribution, again, for those of you with the 84, it's going to be option 4, which is inverse T. The first thing they want is the area. Whether you're using inverse norm or inverse T, that's always 1 minus C divided by 2. So 1 minus, for this example, it was 95% or 0.95. Divided by 2, and the degrees of freedom is 15. So a sample size of 16 produces 15 degrees of freedom. You get that on the home screen. Go ahead and hit enter, and again, that'll give you the negative of the TC, but we want the positive. So just remember to switch the sign on this. So what we should end up getting is going to be 2.13. So that TC should be 2.1, and if you go to 3 places, it'll be 2.131. For those of you that might be using a TI-83 calculator, it does not have the inverse T, in which case this is where this T distribution sheet is going to come in handy. The way that the T distribution will work, what you'll do is you'll first go down to your degrees of freedom, For this one, we said that we had 15 degrees of freedom. So I would scroll down to right here, and then you can look at directly off of the confidence level that's above. So for the exam, we would be using these common confidence levels, predominantly like 90, 95, 98, and 99. Because we had 95% confidence, we trace it down the column, and that would also give us the 2.131. So 2.131. Does anybody have any questions with finding a t-critical value? Okay. We also are able to compute a margin of error using a t-critical value as well. Typically, when you need to use the t-score is when you have a small sample size, and for us, small means less than 30. So if n is less than 30, and in addition, if we don't know the population standard deviation, that's when we use the t-score. The formula for the margin of error in that case is nearly identical to what it was for the ZCritical. You still have a standard deviation. In this case, it's S instead of sigma, but it's still the standard deviation. We still divide by the square root of the sample size, but the only difference is that instead of using the ZCritical, like we did over here, we're going to be using the t-critical score that we got either from the inverse t or from the t table. Does anybody have any questions on calculating the margin of error in 4?
No. No.
Okay. The next thing we come on to is a batch of questions, actually. So 5 through at least 6 or 7. They just simply want us to know what critical score would you use? Would you use a t-score or a z-score? And the criteria is this. So when we have a sufficiently large sample size, so if n is greater than or equal to 30, no matter what, we use ZC. So as long as the sample size is sufficiently large, we're always okay in using the Z-critical score. It's more interesting, though, when n is less than 30. So what happens when we have a small sample size? And the answer is there's 2 cases. If we know the population standard deviation, in other words, if we know sigma, then we can still use ZC. On the other hand, if we don't know sigma, which is just another way of saying we have S instead. So if we have a small sample size and all we have is the sample standard deviation, then that's the one case where we will actually use the t-critical score. So let's come over here and let's kind of look at these. A lot of these sentences are kind of long, but it's really important to kind of pick them apart. Like, for example, when they start off by saying, in a random sample of 28 families, comma, that means that everything else that appears in the rest of the sentence is related to this sample. So first thing we note is that, okay, we have a sample size 28, so that's less than 30. That's the one where we have to be very careful with. And the standard deviation, they don't put the qualifier population or sample in front of it. But remember, this entire remaining sentence is going back and describing that sample. That means that this 22.5 is the sample standard deviation. And then because we have a small sample size with S, that means we're going to be using the t distribution. Does that make sense?
Mm-hmm.
Let's take a look at another one. In question 6, it says, for a sample of 20 IQs, the mean score is 105.8. The standard deviation sigma is 15. Well, we're in the same situation where we have a small sample size, so it's less than 30. So the question then becomes, which standard deviation do we have? Because we were given sigma, that means that we will be able to use the z-score. So we will be able to use the z-score on this one. In question number 7, they say that a random sample of 40 college students, and then we can really stop there. Once n is 30 or more, that's automatically going to be the z-score, because we also know that the population was normally distributed. So more than 30 or more, I should say, that would be the normal distribution. Question 8 is kind of a trick question, if you will. It's not going to be on the exam, but what's going on with number 8 is they give us a small sample size with a standard deviation S. So normally this would be like the t distribution, but they don't say that the information is normally distributed. So one of the things that's kind of important to always kind of remember is whenever we're doing either a z-score or a t-score, we need to know that the underlying information is normally distributed. So normal, assume they're normal, right? So all of these other ones had that extra line in where they say that assume the data set is normal. For our exam, you can assume that every data set and every problem is normally distributed, okay? I'm not going to throw like a curveball on this one where it would be a neither, okay? But technically, they would need to add in the extra line that the information is normally distributed in order for us to use either a z-score or a t-score. Does anybody have any questions on either of 5 through 8?
5 again. I got confused.
Yeah, let's go back to 5. So in question number 5, we have a sample. The sample is of size 28. So n equals to 28. And the standard deviation that they give us is still part of that sample standard deviation. So with n less than 30 and not knowing sigma, that's what makes it the ZC.
Okay.
And let me just pull up that criteria one more time. So in that one we just looked at, we had a sample size of 28, and they told us that the standard deviation was some number. I forget what it was. But that puts us in this case here. Less than 30, and sigma was unknown, and that's when we use the TC.
Okay.
Does that help?
Mm-hmm.
So then the next thing we move on to is constructing the confidence intervals, okay? And there'll be a couple of different types of confidence intervals we're going to be constructing, but the overall theory from this entire section is that the way that you construct a confidence interval is you have your point estimate. For us, the point estimates we used were either sample means or population sample proportions from the last section. But what you do is you take your point estimate, you subtract the margin of error, you take the point estimate, you add the margin of error, and that's how we get our confidence interval. Again, the formulas for E are on the formula sheet. So whether you're doing a confidence interval that uses z-scores or a confidence interval that uses t-scores, those are on there. However, we also know that there's a command in the calculator that can help us with this, and that's either the z interval or t interval, okay? And half the battle, if you're going to be using the calculator, which is perfectly fine, and it's really quick and efficient, is knowing which one to use. So before we go punching this into the calculator, it's very important to understand up front, are we going to do a z interval or are we going to do a t interval? And that all goes back to like that questions 5 through 8. So in number 10, they say construct a 95% confidence interval for the population mean mu. Assume the population is normally distributed. It says we have a sample of 25 randomly selected students, has a mean test score of 81.5 with a standard deviation of 10.2. So the first thing I would do on this one is try to write out the information you have, try to organize it.
I think we missed 9, question 9.
But do it.
Yeah.
Yeah, let's go over 9 first. Thank you for catching that. Let's do 9. Luckily, it's the same type.
Mm-hmm.
So in 9, they say we have a random sample of size 40. So n is going to be equal to 40. They say that the mean of this sample is 3,120 and has a standard deviation of 677. And we want to construct the 95% confidence interval, so 0.95. What would we use for this one? Would we use a ZC or a TC and why?
ZC because n's greater than 30.
Perfect. So n is greater than 30. So we can use the z-score, in other words, or a z interval on this one. So I'm going to go to my calculator. If I can find it somewhere. There it is. So let's go ahead and plug this in. So to do this command, this is going to be under the stat, go over to tests, and we want to do a z interval. This should be choice 7 for all of us. And again, you have two options when you're doing this interval. We could either work off of the stats, if we actually have to enter the data in the data set, or here, we actually have the summary statistics, so we can work off of the stats ribbon. So I'm going to highlight stats and hit enter. And now we're going to just kind of enter the information that they gave us. The calculator just always labels it by default sigma. We know technically it's S, but we're going to put it in anyway. It's 677. Our sample mean was 3,120. Our sample size was 40. And we want the 95% confidence level. So 0.95. Go ahead and hit enter, and that will give us our 95% confidence level. The confidence interval goes from 2,910.2 to 3,329.8. So 2,910.2 to 3,329.8. And then the input commands for the t-score would be the same in terms of how to use the inverse t. Does anybody have any questions on this previous example, on number 9?
Yeah.
Number 10 is going to be mostly the same way, but the difference with number 10 is that we have a sample of 25, which is small, and we only know the sample standard deviation. So for number 10, you would need to use a t interval. You would go to stat, go over to tests, scroll down until we find t interval. That's going to be option 8. Hit enter. Again, we have the summary statistics. Our mean was 81.5. Our standard deviation was 10.2. Our sample size was 25. And we're doing 95% again, so that's going to be 0.95 for our C level. We go ahead and hit enter to calculate it, and that would give us a 95% confidence interval of 77.29 to 85.71. So 77.29 to 85.71. Does anybody have any questions on using the Z interval or the T interval command to construct confidence intervals? From here, it's kind of mostly the same. 11 is very similar, but they do ask kind of a follow-up question later. So in question 11, you have to do both a 99% confidence interval, and then you also have to do a 95% confidence interval. And then they kind of ask, what is the effect on the confidence level? One of the things that you should know is that the way that the confidence level affects the size of the interval is, let's suppose I have like a 95% confidence interval. Okay. So we would be 95% confident that the true population mean, which we don't know, but we'd be 95% confident that the true population mean would be somewhere contained within that interval. Okay. And then if we wanted to be more confident, so think of, I always like to use the analogy in class when I'm face-to-face, is that let's imagine you're trying to catch a fish. So suppose you're like in a pond and you're allowed to pick between two kinds of nets. In order to kind of catch that fish if you wanted to, would you feel more confident using a smaller net or more confident using a bigger net? What do you all think?
Bigger net.
Bigger net, right? Same thing happens with confidence intervals. The more confident you want to be, the larger and the wider the confidence intervals will be. So as the confidence gets larger, the interval gets larger too. Question 12 is very similar, but the difference with question 12 is they actually give us the summary statistics. So in 12, what we would need to do is we would need to plug this information into our calculator first. So we would go to Stat, Edit. I need to clear off this list, and then you would enter these 10 numbers. 3.6, 4.5, 2.8, 6.3. Just continue till you get them all in there. So we have our 10 numbers. And now what you could do next if you wanted to is we could do a calculation on this. We could get the mean and the standard deviation by simply doing stats over to calculate and using that old school one variable statistics command we used all the way back in the beginning of the class. So we would find out that the sample mean is 4.7 and the sample standard deviation, remember that's S, would be about 1.833787, etc. And then once you know that, you can plug it into the T interval. Another way that we can do this, once you have the data entered, is when we go to our stats, when we go to T interval. Does everybody know why we're using T interval on this one?
Mm-hmm.
We have what? A sample of size.
Yeah.
And they didn't tell us the population standard deviation. So small sample size, if we don't know sigma, that means we have to use the T interval. This time, again, you could go off of the stats, or you could just simply go off of the data ribbon because we have all of that data sorted. Our data was in list L1. The frequency we're going to keep is 1 always, and then they want the 95% confidence interval for this. Go ahead and hit enter, and we would get that the confidence interval should be, to the nearest penny, 3.39 to 6.01. So really nothing new. It's still the t-interval command. The only thing that's a little bit different is because we had the raw data set, you would want to enter it into your list first, and then when you go to run the test, instead of working off of the summary stats tab, we can actually pull from the data directly. Does anybody have any questions on number 12?
Yeah.
Let's take a look at number 13. So number 13 is very different in terms of what they're asking for. If you go back through the first half of this test, the question is either of the form, find the Z-critical, find the T-critical, compute a margin of error, or find this confidence interval or that confidence interval. In question 13, what we're asked to do is, with some given information, determine how large of a sample size would be needed to guarantee a certain confidence level. Okay. And we didn't do this for t-scores, but we did do it for z-scores and also for population proportions. And that formula will be on the exam. So if you're looking for minimal sample size, n, it's found by taking z-critical times sigma divided by e, and then it's very important that entire fraction has to be squared. So that whole fraction is going to be squared. So really, it really kind of boils down to, in terms of finding n, sigma will always be provided, e will always be provided, and typically what they will do is give you the confidence level, and we'll need to find ZC just like we kind of did at the very beginning. To find the Z critical, you would do the inverse norm of 1 minus C divided by 2, comma 0, comma 1, and that can give you this value. The only other thing you want to be on the lookout for as it pertains to n, and this is very, very important, is that n does not follow the standard rounding rules. Okay, very similar to what we saw with class size earlier. You always want to round n up. So if n is like 12.7, of course that would round to 13. If n is 12.1, that's also going to round to 13 as well. So when we compute that minimal sample size, it always has to be rounded up. Would anybody like to see maybe A of 13? Everybody good with this? Any questions on 13?
No.
Okay.
So we always round up in that one, right?
Yes, for n, n must always be rounded up. Let's take a look at 14. Now, in 14, we start to get into our population proportion stuff. So instead of trying to sample for a sample mean, x bar, to do a confidence interval for mu, now we're going to create sample proportions. We usually call them p hat, to approximate the population parameter p. To find the value of p hat, it's just the number of successes divided by the total number of trials. So it's the proportion of the population of size n, or of your sample of size n, where x of those elements have the desired quality. So literally for the first one, if they say we sampled 435 college students and 120 of them said that they own a car, then the sample proportion for those that own a car, it's the 120 out of the 435, which would give us 0.276. So to find x bar is a very easy calculation. It's just x divided by n. 15 is kind of the same thing. They want another point estimate for p. That's what we call p hat. If it's 2,650 golfers, 379 of them are left-handed, then that sample proportion is going to be 379 divided by 2,650, and that's going to give us 0.143. In questions 16 and 17, notice that what's being asked for changes. Now the question is how large of a sample size. So we're back to finding n, and it's not for a population mean, it's for the sample proportion. The formula for this, if we're trying to find a minimal sample size for n, it's p hat times q hat, and then times, be very careful here, this fraction is ZC divided by E, and that whole fraction has to be squared. P hat we know how to find. Q hat, kind of like back when we did our binomial stuff, Q hat is just 1 minus P hat. So like, for example, if you find a sample proportion where P hat is, let's say, 0.30, then Q hat is going to be 1 minus P hat, which is 0.70. So Q hat's easy to find once you have P hat, and as it kind of was the case earlier, it really always boils down to kind of finding ZC. You do the inverse norm of 1 minus C divided by 2, comma 0, comma 1, and that will give you n.
So in question 16, how do we know that 4% is E, margin of error?
That's a good question. When they start to say like how much they want it within, the words within or the amount of error you can have, that's the margin of error. So when they say it cannot differ by more than, that means that E is going to be the 0.04. And always make sure you change E to a decimal. So it cannot differ by more than 2%. That's 0.02. That's what gives us the margin of error.
That's because of the word?
Yeah. They could even say like an actual count. So they could say find a sample proportion so that the IQs differ by no more than like 12, in which case your E would be 12. Okay. So E could be given as either a numerical count, or more often it's kind of given in terms of a percentage. Very, very good question.
So in exam, if we see questions like this, then pretty much when we see will not differ, then we know that it's E, right?
That's going to be exactly right. Or if they say can have an error of at most, etc., then that will be E.
Okay.
One of the things, so after looking at 16 and 17, one of the things that reminds me of that I didn't mention, is in number 13. Let me just take a look at number 13 real quick. So one of the things that we saw as it pertains to the minimal sample size. Okay. Actually, I guess it's not number 13. It should be coming up right now. Yeah, so actually it was this here. Number 16. One of the things that we notice is they don't actually give us the P hat or the Q hat value. So something you kind of have to remember from the notes
0.5.
is for the minimal sample size for a proportion. If P hat and Q hat aren't given, use P hat equals 0.5 and Q hat equals 0.5. That's something that some students will leave blank because they feel like there's not enough information. But when we talked about this in the lecture, if usually they'll word it like if there is no preliminary estimate, and if there's no preliminary estimate, then we don't have a value of P hat and Q hat to plug in here. In that case, always use 0.5 for both of them, okay? The next batch of problems actually, are all about finding confidence intervals for proportions. And I think sometimes, for whatever reason, sometimes the numbers will kind of throw students off. In question 18, obviously the sample is of size 50,000. And what we're trying to approximate here, we're trying to get a handle on the true unemployment rate. So from that sample, the sample unemployment rate is 0.058. And they tell us that the margin of error is 0.2%. Be careful with your decimals. That's going to be 0.002. So that's the information. And earlier in this problem set, they say to use, they say that the confidence level. Seems like they're missing the confidence level, but I believe it should be 95%.
I guess in this question, that threw me off because we have to calculate our one ZC. Like, it's a different question. Now we have to use that normal CDF.
Oh, you know what? This one's actually straightforward. Sorry. Yeah, so we only have to use the normal CDF for this one because, let's go back here. Where did my snip go? Ah. I might have deleted it. But when we came up with this, so remember, we already said that we know that the point estimate p hat was equal to 0.058, and they gave us the only other thing we need, which is the 0.002. For the confidence interval with the point estimate p hat, it's just simply going to be p hat minus e to p hat plus e. They did all the hard work where they actually went ahead and calculated the margin of error for us. So literally, to find the confidence interval, all we need to do is we start with our point estimate, we subtract the margin of error, and we take the point estimate and we add the margin of error. That's it. So this would be 0.056 to 0.060. The solutions guide that was posted online might be a little bit confusing to some of you, where I actually kind of showed the working backwards just to show you what confidence level that would go to, but you don't need to know that. The question only asks for the confidence interval, and that's how you would get it for this one.
Oh, so we don't have to do that normal CDF and stuff in this
Not
one?
at all. If you wanted to know what level of confidence this was related to, that would tell you that, but not at all. It's very straightforward. You have point estimate, you have the margin of error. It's just p hat minus e to p hat plus e.
Okay. Because I saw that one, that threw me off because I didn't know that we had to do both.
Yep. That's kind of an oddball where they already give you the information. You just kind of have to put the two pieces together.
Okay.
Ones that would be more common would be things like 19, where they give us the sample size. They tell us the X value, the proportion of the number of people that have that quality, and now they ask for the 95% confidence interval. For that one, it's very straightforward. We have another command for confidence intervals for proportions. That's called the one prop Z interval. You go to stats, you go over to tests. We've already used Z interval in this section. We've already used T interval. And if you go down a little bit more, it should be option A. It's just one proportion, and we only will ever do this with Z intervals. Hit enter, and it's probably one of the most user-friendly commands in the entire class. Literally, all they need to know is three things. What is X, what is N, and what is your confidence level? X was our proportion that said yes, or the number that said yes. That's 150. Our sample size is 495. And they did say to use a 95% confidence level. So we go ahead and we compute it, and what we get is going to be about 0.262, which would round to 2.2. to 0.344. So confidence interval is pretty straightforward. You can use that one prop Z interval for them. Does anybody have any questions on 19?
Mm-mm.
And then 20 is the same way. You can do it by hand if you want to. The formulas are in the formula sheet. But we have N, we have X, we have C. You can just go ahead and use that one prop Z interval. So second, excuse me, no, not second, just stats, tests. Go down to option A, one prop Z interval. For this one, the number X is 197. N is 400. And then they actually ask for the 99% confidence level. So that's going to be 0.99. Go ahead and hit enter. And we would get a confidence interval of 0.428 to 0.557. And then there's a question here. I don't think that I put that on the test this year, but that would be another bonus question. You can look at it if you'd like to. So that's pretty much the review. Again, the thing that's nice is it's just really a couple simple concepts. Knowing how to find critical scores, ZC and TC, knowing when to use each one. The formulas for the margin of error are provided. Sometimes they're going to ask us to find the full confidence intervals. If you're asked to find a confidence interval, it's either going to be a ZC, a Z interval, a T interval, or a one prop Z interval command. And then the only other thing that we're asked for in this entire test is on occasion to find like a minimal sample size. Minimal sample size for a sample mean is here. The minimal sample size for a population proportion would be here. Does anybody have any questions at all from the review?
No, we answered all questions.
Okay.
Are you gonna have a meeting tonight, or is that only for like office hours, or is that only for other days that aren't exams?
Good question. So usually my only evening office hours are on Mondays, unless it's by appointment.
Oh, okay. Thank you. Because I had questions about the homework.
Okay, yeah. Did you want to do them? Do you have time now?
Yeah, I mean, I had emailed you about them too. I was just having problems with a couple parts of it.
Absolutely. I'll tell everybody, let me do this. Here's what I'm going to do. I'm actually going to close this meeting right now just because that will enable Zoom to start to save it. And I'm going to reopen it up because I still have office hours till 10. Let me just close it down right now so I can upload that video. And I'm going to restart my office hours in about 5 minutes. And if you're still available and around, we can do those homework questions then if that's okay.
Okay, thank you.
Right. Hopefully this helped everybody.
It did. Thank you.
Thank you.
Thank you.
You're welcome.